All right, let me open mine up. Okay, part 2.
All right. So the alternative, the null hypothesis for starting at number 9 is that the average or the mean is 529, and then what's it called?
The alternative.
Yeah, the alternative hypothesis is more than 529.
Yep.
And then if, let's see. Oh, and then it asks if a type 1 or type 2 error was committed if the mean score, if you rejected it, but it was actually right. That would be a type 1.
Okay, and then the type 2, so type 1 is you reject a null hypothesis that's actually right. And the type 2 is when, what's the type 2 one again?
It's when you accept a null hypothesis that should be rejected.
Okay. Like the opposite.
Yeah, it's just the opposite.
Okay.
If the analysis were done at alpha equals 0.01, the probability of committing a type 1 error would just be 0.01 or 1%. If we wanted to decrease the probability of making a type 2 error, would we need to increase or decrease the level of significance?
Increase.
Oh yeah, we need to increase. They counteract each other.
Right.
And then 10A, clients. Oh, so this is the real estate agent.
Yeah.
That is talking about people investing in a second home for investment purposes. So that's the question: is this real estate agent's people? Okay.
Is the average age of people buying a second property in his region different than like the national?
Yeah. And then he used a simple random sample, I think.
Yeah.
Yeah, and then the population is just the clients that buy a second home.
Yeah.
All right, and then C, you made a histogram. It looks like this, kind of.
Yeah.
And then
It's gonna look different based on like the bins, right?
Based on the what?
Like, you know how you can put it into different kinds of bins, like 20 through 30 or 25 through 30.
Oh, yeah.
I was making sure.
Yeah, and then you want to ask for the 5-number statistics or 5-number summary. Mine were just slightly off from what the answer key said, but I think I just put one of the numbers in wrong when I did the thing. But they're almost exactly the same.
Yeah, same.
And then D, since there are only 15 pieces of data, since there's only 15, you need to check if the parent population is normal because you don't have a large enough sample size. Yeah. And then, and then the null hypothesis is that the average is 47, and then the alternative hypothesis is that it does not equal 47. And so it's going to be two-tailed because they could be older or younger.
Yeah.
And then...
So is one-tailed to be like if he thought it was only older?
Yeah.
Okay.
So yeah, if they thought that if they had reason to suspect to be older, then it would be right-tailed or something. I don't know. But yeah.
Okay.
And then the z-score, and we know how to calculate a z-score. So
yeah.
Get that. And then put in the applet, you find that the p-value is really large, greater than the 0.05 that we chose for alpha. And so we would fail to reject the null hypothesis. And since we rejected it, then we can say that there's not sufficient evidence to accept the alternative hypothesis. So we stick with the null. And then the last question was so stupid.
What action?
Yeah, what action, if any, do you suggest the realtor take? I said, just chill out. You're a real estate agent. Stop doing statistics.
That's hilarious. For real though, that's a little too much work.
Just sell a house or something. All right, so that's that. I guess we can go to the quiz now.
Okay, yeah. Let me open it up. Hold on, let's see. Lesson 9. Okay, hold on, mine's opening up.
Me too.
Let me make sure this is recording. Okay, yeah, it's recording. All right, you ready?
Yep.
Okay, which hypothesis involves equality? Null, alternative, or true?
Null.
Yeah. Okay. P-value is probability of attaining a sample statistic at least as extreme as the one actually observed. Remember that the p-value is the oh, I just said that again. Okay. When computing the p-value, which hypothesis do you assume to be true? Is it the null?
I think it's still the null.
Yeah. I think that makes sense.
There's 21 questions on this. Oh my gosh.
Wait, what?
There's 21
dang.
questions.
Okay, well, I thought you said 41, so that's a little...
No. Still, 21? Come on.
Yeah, 21.
We just took 2 other 38 question quizzes this week.
That's true. We already had tests. That's okay. We can do it fast. Which represents alternative hypothesis for two-tailed tests? It would be the third one, right? That not equals 10?
Yeah.
Okay. Which represents a left-tailed test? So, let's see, greater...
The first one.
So less than 10.
I think so.
Right?
I think so.
Okay. Yeah, that makes sense. And then right-tailed would be the other one where it's greater than 10.
Yeah.
Okay. Remember, we determined the outcome of a hypothesis test by comparing the p-value to the level of significance. What relationship would result in failing to reject the null hypothesis? So if it's true, well,
so if we fail to reject the null hypothesis, that means the p-value is greater than alpha, right?
Yeah. Okay. Which would result in rejecting. So then it would be less than alpha?
Yeah.
Okay. An insurance company is reviewing its current policy rates. When originally setting the rates, they believed the average claim was $1,500. They're concerned that the true mean is actually higher. Which of the following would be an appropriate alternative? The average claim amount is greater than 1,500.
Yeah.
Okay. Which would be the null. So that would be is equal to, right?
Yeah.
All right. We're cruising. The insurance company randomly selects 40 claims, calculates mean of 1,650. They assume the distribution is normal. Is this a good assumption?
Yeah.
Yeah, because it's a large sample size, or because the population's normal?
Well, it should be the sample size because we don't know that the population's normal, right?
Yeah, that sounds right. What theorem justifies your answer?
Are we gonna have this question on every test from here on out?
I was gonna say we just had this, and yet I'm still like mixing them up.
The central limit theorem.
Yeah. Which of the following is the test statistic as defined in this lesson? The test statistic.
Test statistic should be Z.
Z.
Should be the Z score, right?
I think so. Because the other one is the average, and then the population, and then I don't know what that other one is.
No. Should be Z.
Yeah. Okay. The mean of sales receipts at grocery stores is 150 with a standard deviation of 40. They suspect the average has decreased. There's their hypothesis test. She will use a level of significance of alpha equals 0.05. She takes a random sample of 36 receipts and computes average mean of 144. What is the z-score? Let me get a calculator.
So we got 144 minus 150 divided by
36. Okay, did you get negative 0.9?
what's the sample size?
36.
Negative 0.9.
Yeah,
Yeah.
that's what I got. What is the p-value? Okay, well, we need that. Wait, don't we need the applet?
Yeah, I have it open. So, all right. Well, now, which part should I highlight then?
Yeah.
Oh, so it's less. So it should just be the left part.
Yeah, I think so.
So that's 0.1841.
0.184. Okay.
Yeah.
All right. What inference would we make?
4. So we would fail to reject the null hypothesis.
When do you reject it? If the
p-value is less than alpha. So since alpha is 0.05, right?
Yeah.
And we got 0.184, it's too big.
Okay.
So that's just saying that it's probable that a type 1 error was made. And so it's not enough evidence to reject it.
Okay. So then our conclusion would be, let's see.
I have to scroll up and down all the time.
I know. I think we have insufficient evidence that the true population is less than 150.
Yeah, insufficient evidence of the true population. Yeah.
Right.
I think so.
Because I don't think you can claim that it's 150. You just failed.
Yeah.
Okay. Which one involves rejecting the null hypothesis when the null hypothesis is true? So that's type 1, right?
Sure. I don't want to think about it. It takes too long. If it feels right.
It feels right. A researcher decided that instead of using 0.05, he will use 0.01. Which of the following will be true?
Should be the probability of a type 2 error will increase
Yeah.
because you're decreasing the probability of a type 1 error.
Yeah. That makes sense. Okay. If alpha is 0.05, compute the probability of committing a type 1 error. Isn't it just 5%?
Yeah, well, how do they want it? Should just be 0.05 still.
Yeah, I guess so, because it just says around 2 decimal places. Okay. Submit this. Processing. 100.
Yes, thank goodness.
I know, right? I wonder what the other half of our group got.
100. I don't know if they did it as speedy though.
Yeah, that's true. We did go pretty fast. Okay, cool. So I'll just post this in the comments of Kaylee's video, right?
Yeah.
Okay. Sounds good.
All right.
All right. Thanks for meeting late.
No problem.
All right. See you later.
Bye.